Hi, everyone. This is the first question on the written homework for Chapter 12, and I'm making this video just to get you started, so I don't want to do the problem for you. I just want to kind of make sure I clear up any misconceptions that often arise from this problem. So first I've written down the information from the problem. It says 43% of the U.S. population is type O blood, 40% is type A, and 10% is type B. And then it says the rest is type AB. So notice here we need this to add up to 100%. So if I add these together, I've got 83% plus 10% is 93%, which means that the rest of the population that has type AB blood is 7%. And this would mean then that the probability that a person has type O blood, let me spell type right. Sorry, let me get my eraser here. Is going to be 0.43, and the probability that somebody is type A is going to be 0.4. And the probability that somebody is type B is going to be 0.1. And the probability that somebody is type AB is going to be 0.07. So we're going to use these values to answer parts A, B, C, and D. Just a couple of notes. So first, it's not possible for a person to have more than one blood type. Okay, I'm going to say it's not possible for a typical person. I'm pretty sure I saw a Law and Order episode where somebody had, two blood types and that's why they got away with a murder. But we're talking about typical people here. Also, this type AB blood, that is a separate type than type A and type B. So don't think of that like those two types together or combine those probabilities in some way. So for part A, it says, what is the probability that a randomly chosen person is either type O or type B? So we're looking for the probability that a person is type O or type B. And because it's not possible for somebody to be both type O and type B, this or question is simply the probability of type O plus the probability of type B. And I'll let you finish the problem from there. For part A, we were talking about one single person. For part B, we're talking about two people. And we're assuming that these are two randomly chosen people. Maybe that word randomly chosen should be in there in my directions. But these are two randomly chosen people. What is the probability that both people have type AB blood? So we're looking for person 1 to have type AB blood. Oops, I didn't want to close my bracket there. And person 2 to have type AB blood. And since we're randomly choosing these people, this would mean that they are independent, and this should equal the probability that person 1 is type AB times person 2 is type AB. Now, the probability that person 1 is type AB is the same as the probability of person 2 being type AB. It's this probability down here. But because we have two people, we are multiplying this together twice. So keep that same idea when you're looking at for part C and D, because notice in part C we have 3 people, so we're going to be multiplying 3 times, and in part D we have 4 people. In part C, again, I'm going to let you finish part B here. In part C, it says, what is the probability that none of the 3 people examined have type AB blood. So first, before we start multiplying, let's figure out the probability that a person does not have type A blood. So not type A. So not type A is the complement of type A. So we can say that this is the same as 1 minus the probability that a person is type A. So notice that the probability that somebody is type A is 0.4. So the probability that somebody is not type A should be 0.6. And then take into consideration that you have 3 people, and go ahead and finish this problem. For part D, it says we have 4 people. What's the probability that at least one person has type A blood? Type B blood. So we have 4 people, and at least one of them has type B blood. So at least one means one of these people, or 2, or 3, or 4. Now I could go through each one of those scenarios, but it's a lot easier to say that there's only one scenario left, and that's that nobody has type B blood, which means that the probability that at least one person has type B blood is the complement to the probability that no one of these 4 people has type B blood. So the probability that at least one of these 4 have type B blood is the complement of the probability that none are type B. And what is the probability of... So, sorry, I had to pause for a second. So we're looking for the probability that no one has type B blood. So before we come to this, let's figure out what is the probability that you don't have, that a randomly chosen person is not type B. So this is going to follow what we did in part C, where this is the complement that somebody is type B. And type B is 10%, so this is the complement of 10%, which means that you have a 90% chance of being not type B. So then when we come back to this idea here, this is going to equal 1 minus the probability that all 4 people are not type B. So the probability that we're not type B times the probability of not type B, I have to write this 4 times here, times the probability of not type B. I don't think I'm going to fit this. Times 1 more, probability of not type B. So you're going to take 1 minus this 0.9 times itself 4 times. So I'll let you finish up that problem. Please let me know if you have any other questions on this homework problem.